Section 2.2 is all about different forms of quadratics. If you remember from Algebra 1, there are 3 different forms of quadratics that we really look at. The first form that we're going to look at is vertex form. The second form that's going to be useful to us is standard form. And the third form that's going to be useful to us is factored or intercept form. Okay, these 3 forms all tell me different things about the quadratic. For example, if I look at vertex form that I highlighted here in yellow, that tells me where the vertex of the quadratic lives. So if you remember from your 2.1 notes, when we graph quadratics, it's very helpful for them to be in vertex form because this H and the K give us our horizontal and vertical shift. Meaning that when we start graphing a quadratic, let's say it tells us to move to the right however many spaces and then down so many spaces, that's where we start our vertex so that we can get our then over and up pattern and make the nice parabola shape. Standard form is really nice because it tells us our y-intercept. So again, a y-intercept is wherever your graph crosses the y-axis. And lastly, factored form or intercept form, if it looks just like this, is always going to tell us our 2 x-intercepts. So on a graph, if this is my parabola, it could look something like this. Okay. And there are different processes that we use to get from one form to the other. So let's start doing some practice problems. The first thing I want to do is identify which form is given to me, and then I want to change it into standard form. We do that by performing order of operations. So in this first example, if I look 2 times x plus 1 times x minus 3, I'm trying to get that into standard form, and when I look at it, it does not necessarily look like vertex form. There's not one thing being squared. It looks more like factored or intercept form. There's an a value with the 2, and then 2 sets of parentheses that are being multiplied. So I'm starting in factored form, and I want to get this thing in standard form, meaning I'll do order of operations. When I look at this, when things are squished together in math, like this 2, the parentheses x plus 1, and the parentheses x minus 3, that's telling me to multiply. So I can multiply in whatever order, but I'm going to multiply piece by piece. So when I say that, I'm going to take this 2, and I'm going to multiply it by the x plus 1. That's what it's being squished right next to and being multiplied by. So when I distribute the 2, I get 2x plus 2 now. I still have not touched the x minus 3 though. So now I'm going to distribute again, and remembering from Algebra 1, when we distribute, this 2x is going to get multiplied by both terms over here, and the positive 2 is also going to get multiplied by those same 2 terms. So let's start with our 2x. 2x times x, I know is 2x squared. 2x times negative 3 is negative 6x. So this 2x got multiplied by both of the terms in the second parentheses. Now I do the same thing with this 2. 2 times x is 2x, and 2 times negative 3 is negative 6. When I look here, I see that negative 6x and 2x are like terms, and I can combine them. 2x squared does not have another x squared that I can combine with. Negative 6x plus 2x is negative 4x, and negative 6 does not have a like term. So when I compare this, it looks like it is in standard form. Let's go to the next one. I see y equals parentheses x plus 2 squared minus 3. I know that this quadratic is in vertex form. The way I know it's in vertex form is because there's one term here, this x plus 2, that's being squared, similar to the x minus h up here. So to get this in standard form, I'm going to start looking at order of operations. And when I think about order of operations, it tells me do things inside the parentheses first. That's what the P stands for, parentheses. But when I look inside the parentheses, there's nothing I can do with x plus 2. I can't combine those right now. So then I move on to the e exponent, and I do see an exponent here of 2. When I know that I'm squaring something, that means multiply by itself. So if I'm multiplying x plus 2 by itself, I have to write it 2 times. So I took care of the squaring, and now I need to go on to the multiplying, just like we did in the previous problem. x plus 2 times x plus 2. I'm not going to worry about this minus 3 yet. It's not part of the multiplying process. When I distribute, I know that x times x is x squared. X times 2 is 2x. Now I move on to this 2. 2 times x is also 2x. And 2 times 2 is 4. But I can't forget about this minus 3 at the very end. So now I look just like I did in the previous problem for like terms. X squared does not have a like term, but 2x and 2x can go together to make 4x, and 4 minus 3 can go together to make positive 1. Now we have our quadratic in standard form. Okay. Trying the next two, well, this next one is in factored form. Again, the way I know it's in factored form is because I see multiplying, but I don't see in vertex form anything being squared. So to get it into standard form, I'm just going to do order of operations by distributing the 4x. 4x times x is 4x squared, and 4x times negative 2 is negative 8x. Those two things are not like terms, so I'm done. The last one, negative 2 times x minus 3 squared plus 5, we see one term that's being squared, so I know it's in vertex form. And I want to get it into standard form, so I'll start kind of like I did with the problem up above. The only difference this time is there's a negative 2 coefficient out in front. But I'm still going to square my x minus 3 by writing it twice. And now I can use the skill that I used in this first problem where I distribute my negative 2 into the first parentheses to get negative 2x plus 6. Then I'm going to multiply that by the x minus 3 and have my plus 5 at the end. So if I distribute here, negative 2x times positive x is negative 2x squared. Negative 2x times negative 3 is positive 6x. I took this negative 2x and I multiplied it by both of the terms in my other parentheses, so I'm good there. I'll move on to this positive 6 times x is positive 6x. And positive 6 times negative 3 is negative 18. And I still have the plus 5 from the end. When I combine my like terms here, this negative 2x squared does not have a like term. 6x plus 6x makes 12x. And negative 18 plus 5 makes negative 13.